as we get into nanotechnologies?
Yeah, nanotechnology, we call this NEMS, nano electromechanical systems. So they're actually building resonators that are almost hair-like. In your ear, you actually have these hair filaments that sense sound. We're duplicating that. We're making very tiny piezoelectric fiber-like structures. Those can be used for audio applications, radio frequency applications. And then, of course, you can leverage everything that leading edge node semiconductors can do. You can two-dimensionally pattern things in the nano geometries. And that is slowly being adopted by the MEMS community. Typically, MEMS devices right now are in the, I would say, 100 nanometer and bigger line widths. So it's kind of a trailing edge technology. We like to think of it as a more than more technology. So it's not following Moore's law, but it's doing some strange things at these larger geometry levels that can't be done with traditional semiconductor wafer fabrication. And whether that's three-dimensional structures, alternate materials. I recently did a project for a number of years where I was 3D printing stainless steel wafers or titanium wafers for very harsh environments. So you're building up these resonators out of titanium using three-dimensional printing, laser printing. And you're instead of using silicon, because silicon's a fragile material, it's not corrosion resistant per se. And so the MEMS technology allows you to look at a whole broad spectrum of materials to select from, and then interleave that in with traditional semiconductor layers and lithography techniques.
Wow, that is exciting. Now, as you know, traditional electronics has gone up to almost the angstrom level with 3 nanometers, 2 nanometers. Does that mean that MEMS and NEMS have a long way to go and they can continue to shrink and continue to follow something like Moore's law going forward?
I think they will. There's really no limiting factor other than it's a more expensive. Obviously, the 300 millimeter, 2 nanometer wafers are extremely expensive. You know, only Apple can afford to buy them. MEMS technology is so widely dispersed, and it's more of mature node technology. But like any mature node technology, as the capital costs go down for these tools, they'll be adopted by a wider and wider spectrum of applications and